right? So let's see, I'm looking for my pen. Since that was the question for sure, and I think this problem was, let's see. I'm looking through the problems right now, and I'm looking for the Newton's law of cooling right now. So I believe this is, oh, Newton's law of cooling was actually in the second quiz, am I right?
Yes.
Yes, that's right. So anyway, let's start with the first then. First problem, we have here this differential equation. So everybody please write along with me, don't just watch, but actually have a pencil or pen and write it all down on paper. I think this will work best for us because it will help you to understand the material better. So let me copy this problem. And by the way, I do have my projector back. I believe it's fixed now. So I will be writing on paper today. So let me copy down. This is math 270, section 1, and today's April 30th. We're going to review number 1 from quiz 1. And this problem here is a differential equation, dy dx equals x to the 6, y to the negative 3, this is important, y of 0 equals to 9. Now, your problem is probably different from mine because there are different versions of the same test, of the same problem. Our objective is to find the solution and write the interval of existence, right? So these are the questions. Let's start with solving this differential equation. It's separable. Am I correct?
Yes.
Okay. So let us examine the DE, the differential equation first. Did you notice that we have y cubed in the denominator? This is extremely important to notice. If you have y in the denominator, that means if y is 0, derivative dy dx does not exist. Do you agree?
Yes.
So this is very important. We will observe it right away. To the projector, so I started writing here. This is going to be important when you have to determine the interval of existence. So this is used to find the interval of existence. The interval of existence.
We're still on the Blackboard page right now. We can't see your scratch paper.
Yeah, the screen is like frozen.
I'm sorry, did you say you cannot see what I'm writing?
Now we can.
The connection's pretty bad.
Oh,
Yeah, like you froze a few times.
Oh, okay. So now, can you see my my writing?
Yeah.
Yes, we can.
You cannot?
You can.
We can.
We can.
Okay, so can you give me a few moments? I'll have to, let me see if what I can do. Give me a few moments, okay? Just, I'll be right back. Hello, can you see anything now?
Yes.
Can you see my notes?
Yes.
Okay, so I don't know. So let's try, and if it still doesn't work, I will try again, I guess. So are there any questions about any of this so far?
Is it okay if you can zoom in just a little bit?
Yes, absolutely. How about now?
Yeah,
So,
that's good. Thank you.
Okay, so perfect. We observe again, derivative dy dx does not exist if y is 0. So we made observation, and we're going to return back to this when it's time to find the interval of existence. Okay. So to solve this, we're going to pretty much cross multiply, right? So we need to have all everything containing y on left-hand side and everything containing x on the right-hand side. So we get y cubed dy equals x to the 6 dx. So let's integrate, right? Let's integrate. This is y to the 4 divided by 4. X to the 7 over 7 plus some constant of integration. We will see. Okay, so next step is to multiply by 4 both sides. And finally, I'm going to take 4th root of both sides. When we do that, technically it's plus or minus, right? We will have to choose which one when we examine the initial condition. So it's either plus or minus, but which one to choose? It cannot be both. So let's see, 4 over 7, x to the 7 plus, this is 4th root. Are there any questions so far? Let us find now C for this problem. It says here that y of 0 equals positive 9. Since it's positive 9, which one to choose, plus or minus?
Positive.
Well, let's see. So again, y of 0, it's supposed to be equal to 9 if I plug in 0 here. So for the equation to work, we will have to choose which one, plus or minus. Right, y of 0 equals to positive 9. So that means you have to choose the positive one. So we get 4th root, then we have 0 plus 4c. Let's see. I should probably zoom out just one more time so that I can try to squeeze both pages on the same screen. Let me know if that doesn't work. So So 9 to the power of 4 equals 4c. I raise both sides to the power of 4, from which c equals 9 to the 4 over 4. We can use calculators to find this number, or let's see if we can get a nice decimal form. Hopefully it will terminate divided by 4. So yes, it's a nice terminating 1640.25. Do you agree with this so far? Yeah. Okay. We found C. We're ready to plug that into the solution. So we get y equals. So again, we're using the positive one. This is 4th root. Under the root, we have 4 over 7, x to the power 7, and then plus, instead of C, I'm writing, you know what? It's actually more beneficial to write it as 9 to the 4 over 4, so I can cancel 4. Do you agree? Four over 7, x to the 7 plus, and then I'm just going to find 9 to the power 4. So I type 9 to the 4, and I'm getting 6561. So please let me know, are you getting the same? I honestly hope that you're doing this on paper. And you are trying to do this independently, because this is the only way to learn. Is there somebody who could confirm this answer? Anybody got this answer?
Yeah.
All right, so for the purpose of typing this, I'm going to rewrite this root as an exponent. So I'm going to use a quarter, right? The exponent is 1 over 4, and this is what I intend to type. Hopefully it will work into the program. So any questions about this is particular solution. What we see here, this is particular solution. So this function is nice. There is no denominator to worry about. However, let's keep in mind, we have a problem when y is equal to 0. So we need to find that x value for which this derivative does not exist. So we will set y equal to 0. Remember, we return now to this part here. We said y equals to 0 is a troublemaker. We have to find when y is equal to 0. So I'm setting expression under the root equal to 0. And I'm going to solve it. So 4 over 7 x to the 7 equals negative 6561. I'm going to multiply both sides by 7 quarters. 7 over 4. So x to the 7 here. So 6561 times 7 divided by 4. So I'm getting let me keep it as negative 6561 times 7 over 4. And then I'm taking 7th root of that quantity. So I'm going to take 7th root. That means you can bring minus up front because the root is odd. And I'm going to keep my answer this way. So this is the troublemaker. This is the bad x value. And I'm going to place it on the number line. This is 7th root 6561 times 7 over 4. So there are two sides here, two subintervals. Which one do we choose? We have to use this initial condition, right? Which one, to the left or to the right?
The right.
Left.
Yes, to the right. This is the one to use, right? So I would probably write my interval of existence as follows. we would say it's from negative 7th root 6561 times 7 over 4 and then comma positive infinity close parenthesis. So this is the interval of existence that I'm getting. Could somebody confirm this? Are you getting the same?
Yeah, I got that.
You got the same? Okay. So, well, let's type this into the program and see what happens. No, that's not your class, this one. So I'm going to web work. Wait a minute. Oh, this is Blackboard quiz. Okay, so this is the Blackboard quiz and this one, yeah, this one is web work. So let us type this. So I'm typing this answer that I got here, open parentheses, 4 over 7. So I will open another set of parentheses, type 4 over 7 times, where is my times here? Times x to the 7, x to the 7 plus, excuse me, 65, 61, close parentheses, exponent. A quarter you can type as 0.25 or you can type it as open parentheses 1 divided by 4. And I believe that's our, I'm just checking, making sure. Also, there should be a preview somewhere here. Let me, yeah, there is a way to preview this. Let me see what, does this look like what we got? 4 over 7 x to the 7 plus 65, 61 to the power quarter. Yeah, I believe this is what we, what I wanted to type in. And over here, I'm going to type negative, then I open parentheses. I type 65, 61 times 7, what is times 7, and then I divide that by 4, and then close parentheses to the power. This time the power is 1 over 7, so I'm going to open close parentheses. Over here, I would have to type positive infinity.
Wouldn't you need another set of parentheses for your dividing by 4 on the left side? Because right now it would most likely think you're multiplying by 7/4.
So this is about here, right?
No, the solution defined on the interval.
Oh, this one?
Right.
Let me see. 7/4. Oh, you want to put parentheses here, right?
Right.
I think it should accept the way I typed because you only have multiplication and division here. So that means it will be executed from left to right.
Oh,
But
okay, okay.
you can never be too careful, so it will not hurt if you put extra set of parentheses. So I added extra set of parentheses just in case. See, the problem would be here. If you leave it as exponent to the 1 over 4, then it would accept 1 as exponent, and 4 would go in the denominator of the entire expression. So let me preview this as well. Yes, this is what I wanted to look like, provided it's correct. I believe it's correct. So let's see, 65, 61, 7 over 4 to the power 1, 7, and there's minus in front, infinity. So I want to show correct answers and show solutions. Well, if I click on grade test, I will not be able to solve other problems, right? So are there any questions about this problem? I'm thinking about Do you want me to check solutions now, or do you want to look at other problems in this quiz?
Probably look at other problems too.
Other problems too. Okay, so, well, let me move to the next problem. So I'll click on this. I'm going to number 2 right now, and I want to see what is in number 1 because I'm curious. And it still has my typing here, right? It still has all my typing, so I kind of move to the next problem. The next one is about radioactive decay. You have to find the half-life of the element in days and how long to decay to 97. Okay, so let us write down the information and solve it on paper first. Problem number 2, we have the following. In 300 days, the radioactivity of a sample decreases by 30%. So we had some initial P sub 0. I'm just going to name it as P sub 0, and we're told that P of 300 days, right? 300 days is 30%, so it's 0.3 times P sub 0. Am I correct? And our question is, what is the half-life of the element? Find T 1/2, half-life. So this is what I wrote down over here. I have, again, some unknown, it's not given to us. P sub 0, the initial quantity is not given, but we do know that after 300 days, we have only 30% of that initial quantity. Do you agree? So here's the formula for the radioactive decay minus lambda T. I'm not deriving this anymore. I already derived this some time ago when we discussed radioactive decay. And I also, again, this one I remember, but I would probably put it on the index card if I had to take a test. So I'm going to plug in this quantity, this number of days, and see what is lambda. So we have 0.3 times P sub 0 equals P sub 0 E minus lambda times 300 days. Divide both sides by P sub 0, and you get 0.3 equals E minus lambda 300, right? So we will, excuse me. So yes, we will take ln of both sides, ln, and cancel here. So we get ln of 0.3 equals negative lambda times 300. I'm going to divide both sides by negative 300. So let me ask you this question quickly. This is actually plus lambda. I'm going to white out. So let me ask you a quick question. Which one do you prefer? Do you prefer me to write with the projector on paper, or do you prefer me to write on iPad using my Apple Pencil? Which method is better for you?
Projector. I like the projector.
Projector? Is everybody, is this, everybody thinks this way, or is it different for different people?
It seems like everyone likes the projector way.
Okay, great. So I just wanted to make sure because it works now, it got fixed. I believe for now it's fixed. So I'll keep using then, personally, I also prefer it. It's more comfortable, and you know, I don't have to struggle with. Sometimes the pen doesn't work, or the pencil, the Apple Pencil doesn't work, or something else happens with the screen. So yeah, this one is probably better for me as well. So let us find this lambda using calculator. So I'm taking ln of 0.3 divided by, open parenthesis, negative 300. And I'm getting this lambda. I'm getting 0.004013243. Can anybody confirm, please?
Yes. Yeah.
Excellent, thank you. So let's try to find the half-life now. So I'm going to, half-life means we have 50% of the initial amount left, right? So it's 0.5 p sub 0 equals p sub 0 e negative lambda t sub 1/2, where lambda is this number right here. So I'm going to move to the next. So this was number 3. And number 4. We can cancel p sub 0, and we end up with 0.5 equals e to the negative. Instead of lambda, I'm going to write this entire long number. I'm keeping all my decimal places because this is not my final answer. I don't want any round of error at this time. So it's a little long, but and I could probably shorten a little bit, but that's okay. I'm just keeping all my digits here. So take a ln of both sides. And finally, divide both sides by lambda to find the half-life. So ln of 0.5 over this number. And here we have our answer. So take ln of 0.5, divide by, open parenthesis, negative 0.004013243, close parenthesis. My answer is 172.714979. So this is in days. Can anybody confirm this?
Yes, we got.
Excellent. And again, I really hope that everybody is trying to work hard on this right now, because this will help you later, because any of the problems you see here could show up on, something similar could show up on your midterm or final. So please make sure it's all clear. Let us now see what else. Is there another question in this problem? I'm looking at, yes, they want to find how long will it take for a sample of 100 milligrams to decay to 97 milligrams. So for part B, we would have to set, so 97 equals, this is the initial, right? 100 milligrams, sample of 100 milligrams decayed to 97 milligrams. And we will have to substitute, again, lambda. And then T sub 1/2 would be 1/7, oh, I'm sorry, not that one. We just put T here, right? We need to find the time needed. So let me clear this. And I'm just going to call it T. So this is T. Let's solve for T. I'm going to divide both sides by 100.
Professor,
Yes?
I can't see your projector.
Yes, you're right. I forgot about that. Take a ln of both sides. and divide both sides by this lambda here, negative lambda, and we should be getting our answer here. So we have 7 days and actually more close to 8 days, right? 7.589674,357 days. This is what I'm getting here. Can anybody confirm this?
Yeah, that's what I got.
Excellent, excellent. So I will type that in here. So I have a half-life, let me copy this to the screen. Half-life 172 point, now since they don't say how many decimal spaces, I'm going to just type the whole thing, 172.714979. So I typed pretty much the entire, my entire answer. I believe I copied that correctly. So next number is 7.589674,357. So this is the number I got here for the number of days. We can preview and, well, that's exactly the same thing. Any questions here, number 2?
I have a question.
What's the question?
So in the first part, we multiplied P of naught by 0.3, but doesn't that mean that we're left with 30% of the initial quantity? So wouldn't you multiply by 70%, like 0.7, and then proceed the same way?
Sure, let's see. Oh, let me read that again. In 300 days, the radioactivity of a sample decrease. Oh, okay, I see what you're saying. A sample radioactivity of a sample decreases by 30%. So I think we interpreted this wrong. What I wrote here in my problem, let me see again. So the radioactivity decreases by 30%. So that means only 70% left. Is this correct?
I believe so, yeah.
You're right. The whole problem is wrong now. Sorry about that. Yes, I solved it wrong. And the reason is if radioactivity decreased by 30%, that implies that 70% of the substance is left. Is this correct?
Yes.
Okay, so I wish you spoke a little earlier.
Sorry.
About like 20 minutes ago. But I'm glad you said, anyway, I'm glad you said that because otherwise we would, yeah, this is wrong. So unfortunately, I will have to make correction here. So instead of 30%, we have 70% left. Am I right? So I would have to cross this out and replace my 3 by 7. So 70% left. And unfortunately, that will influence the rest of this problem. So instead of 30%, we have 70 left. So this number will be changed. Again, I wish you spoke earlier because the entire problem all the way down to the end is wrong because your lambda is wrong. And we use lambda over here, right?
Yeah.
Well, yeah, we will have to redo this. I apologize. So I'm changing my number. So ln of 0.7, right, divided by negative 300. And I'm getting completely different lambda here. So my lambda this time is 0.001188 916. Does everybody follow here? What happened? Is everybody following?
Yes.
Thank you. So again, I apologize for the mistake. So yeah, you have to read carefully. We didn't read carefully. I didn't read carefully. And the result of this is mistake that goes all the way down to the end of this problem. So this lambda is not correct anymore. So this lambda will have to get replaced. So my number of days will change, unfortunately. So let me do that. We still have ln of 0.5 on top, ln of 0.5, and we divide it by negative. So I just need to change this number, 0.0011888916, close parentheses. And the number of days that I'm getting here is 583.0076.982. So this is the number I'm getting for half-life. So it would take about this many days to get 50% of the substance. Any questions here? So again, I'm going back. This is the wrong screen. Yeah, I'm going back here, and this number that I typed, that would be wrong. I'm typing 583.00.769. 82. So any questions so far? Any questions? So same for B, we would have to replace, unfortunately, we're still using the same lambda, so we have to replace that by the correct one, 0.0011888916, right? And that means this number will change. We will have to take ln of 0.97 and divide that by open parentheses negative 0.0011888916 close parentheses and 25.619309993. This is the number I'm getting here. And I have to replace this number right here by this new one. By the way, is anybody getting the same numbers this time?
I'm getting slightly different numbers, like farther into the decimal, but like the whole numbers and everything are still right.
Okay, so how far, which decimal place is not the same?
I think it's like probably 5 or 6 decimals out, so it's a really, really small difference.
Okay, so this is, yeah, 5, 6 should be fine. You're talking about the final answers, right? Half-life and the final answer that I'm typing. Are those slightly different?
Yeah, it's just like slightly different. Like I have 25.619299916.
So that's the 4th decimal place. 4. Did you keep the same number of decimal places for lambdas? For lambda?
For the lambda, my calculator saves 1 more digit than that. It was point, like whatever 0.00005 more.
Okay, so okay, so let me so I'm going to well, preview. This is what I typed, right? This is what I got, and I typed these numbers. So I'm getting really curious about my answers, and I'm going to submit my test, I think. And then I'll see from there. So again, if you don't mind, I'll check because it's getting too much, so I'm going to grade it. Okay, so clearly my score is low because I didn't do the rest of the quiz, right? The other 3 problems. So let me go back to, I want to see, so this one was accepted as correct. And number 1, I don't see, show correct answers and show solutions, check test. I don't see anything. Let me see. Oh yes, it says correct, correct, correct. So everything is accepted as correct for the first 2 problems. And the rest we haven't attempted, so I'm going to go to number 3. So tell me, do you want me to solve this problem, or do you think this one is okay?
I think this one's okay.
Do you want me to do this problem?
Yeah.
Yes, please.
Okay, so number 3. So number 3. So let me. Okay, so I'm going to ask you to start without me, and I'll be back in about 1 minute. Okay? Thank you. What happened? Hello. So I apologize for the delay. I had a family emergency, so I had to take a look there. So for number 3, we have y of t. We know it's a solution. So you can hear me, right?
Yeah.
Perfect, thank you. So this is the differential equation I'm copying right now on my on the paper. So the question is, what are the constants k and y sub 0? So we want to find k and we want to find y sub 0 to make sure this is indeed a solution, right? So I'm going to take derivative of this y. We know it's a solution, right? This is solution for sure. I'm going to differentiate it, take derivative. This is y prime. Do you agree with this? Is everybody getting the same derivative so far?
Yeah.
Perfect. So I will substitute this into this equation, differential equation. So y prime, right, plus k times y has to be equal to 0. So let's add 36e to the negative 4t to both sides. So we will divide both sides by e to the negative 4t, and also we will divide by 9. So 36 over 9 is 4. So we found k, excuse me. And to find y sub 0, I would have to take this function and substitute 0 for t. So I'm getting 9 times e to the 0, which is 9. So this one is our y sub 0. Now we're going back to our quiz. Actually, it's too late to type now because the test has been submitted, but it's okay. We can at least check the solution. So show correct answers and solutions. Let me see what happens if I just click on check test. Well, it says correct, but the score is still the same, right? 4 out of 10. Because I submitted the first time and that was the score. So any questions on number 3 from quiz 1?
Can you go back to the work really quick?
Sure. So this is number 3. Any questions? So I am going to move on to the next problem. Am I correct? So moving to number 4 now, and this is the one where you have to match. No, you don't need to match. You just need to figure out which ones are separable differential equations. So separable means you can. Let me move here. So number 4, separable equation means that you can rewrite the right-hand side, the left-hand side is dy dt alone, and the right-hand side is a product of two functions, f of t times g of t. If you can write your equation in this form, this will be separable. Differential equation. So I'm going back to look at my list. So let's look at the first one. Can we break this right-hand side and write it as a product where one function, yes, one function is a function of x only and the other one is a function of y only. Oh, and going back to my writing should be one is a function of y, the other one is a function of t. Please correct if you copied the original writing. So please correct, function f is a function of y only, and function g is a function of t only. So I'm going back here, and I labeled this as separable because our function e can be written as a product, right? We can say e to the power 3x plus 2y can be written as product e of 3x times e to the 2y. So here is what I wrote. E to the power 3x plus 2y can be broken into product e of 3x, e to the 3x times e to the 2y. Any questions so far? How about B? Can you do the same here in part B?
No.
No, we cannot. Yeah, that's not allowed. You cannot just break it into. You cannot separate here. How about part C? For this one, I'm going to copy the equation on paper and I'm going to investigate. So I'm copying the equation. It's x 1 plus y squared to the power 1/2 dx And here we have y1 plus x squared to the 1/2 dy. So I copied the equation. I believe I copied it correctly. So let me move here. And I'm going to try to separate it. So I'm going to leave all expressions containing y on one side and everything with x on the other side. So I'm actually separating right now. Do you agree with this separation?
Yes.
Thank you. So this side contains y only, this side contains x only. So yes, we separated it. It's separable. Therefore, I'm going to go ahead and put a check here. How about the next in part D? Can you break this into product of two functions? Is this
No.
separable? No, we cannot. You're right. There's no way. You cannot break the square root because you have a plus. This is a plus, not multiplication. So you cannot separate this way. How about this next one? What do you think?
Yes.
Yeah.
Yes, I think we can separate, and all we have to do is divide both sides by ln of x, multiply both sides by dx, divide both sides by x plus 1 squared. Do you agree? How about the last one?
No.
We cannot, you're right. We cannot do that here. This equation is linear, but it's not separable. So we're getting 3, A, C, and E, right? So let's see, show correct and show solutions. So any questions here? So the last one is the tedious one, right? That's where you have to see match each differential equation to a function, which is a solution. Here are the functions, and here you're supposed to type what is the corresponding solution, right? So let's see, the best way is probably, let me copy, this is number 5. I'm going to start with sine. Sine is probably a solution of either second or third. So I will try sine first. So let me start over here. Our function y is sine of x. And I'm wondering if there is any way to maybe split the screen in 2 pieces and, oh well, so I'll just copy, I think it's probably number 3. So let me try y double prime plus y equals to 0. And the reason I want to try that is because if you differentiate sine twice, you will still get sine with a minus, right? Let me see, y prime is cosine, right? And y double prime is negative sine. So yeah, if I plug in a y double prime and plug in y here, so sine equals to 0, yeah, everything cancels out and we have a true statement. So yes, I'm ready to put, over here, I'm going to put C, over here, C. What else? Let's see, what else is here? E. I will try E. I think E is a very convenient function because derivative of E, well, we have to use the chain rule here. So let me copy that one. So let's try y equals e to the negative 6x. I'm going to take derivative of this. I'm getting negative 6e to the negative 6x. Any questions so far? I will take the second derivative just in case, because I might have to use it as well. So 36e to the negative 6x. Do you agree so far? So again, don't be afraid to speak up. The sooner the later, the better, especially with tedious problems. So let's go back to this test, and I'm wondering, well, so I'm not going to check 3 anymore. I know it's not 3. So how about number 4? No, 4 doesn't look right because we have minus 6 in front of the derivative. Any suggestions which one to try next? Perhaps number 2 or 1. So I'll start with number 2. So yeah, in this case, in this type of problem, you just have to use your best guess. So this is number 2, and I'm going to substitute my I have it all prepared right here on this page. So I'm using this y, this is y prime, this is y double prime. So I have 36e to the negative 6x plus 12 times y prime, and then plus 36 times y. I think this will work because this is 72 here, and this is negative 72. Everything cancels out. So yes, it looks like we just found that number 2 has answer B. Do you agree?
Yes.
Very good. Let's see, let's continue. We only have 2 more left. And I guess I'll try A. Let me see, A is y equals 3x plus x squared. I'm taking derivative of it. If you differentiate a polynomial, 3 plus 2x, and y double prime will be just 2. So that's convenient. Shouldn't take long. So let's see. Well, let's try number 1, maybe. Yeah, I don't think it's number 4. That's because your function has quadratic term there, while derivative doesn't have quadratic term. So yeah, we'll try number 1 for it. Xy prime minus y equals x squared. And I'm going to go back here and plug everything into my differential equation. And hopefully it will work. Let's see, 3x plus 2x squared minus 3x minus x squared. Let's see if this is true or false. I believe it's true. Yes. Great, so we found that over here the answer is A. And we just have one more equation, and I'm thinking the E part, E should work because derivative of exponential is still exponential function, so it will probably be easier to satisfy number 4. So let me copy down. Part E has y equals 2e to the 4x, and the suspected differential equation is probably, well, that's the only one left, y prime equals 4y. Switching back to the paper. So first derivative here is 8e to the 4x. Am I right? Using the chain rule.
Yes.
Excellent. Equals 4 times 2. Yes, yes, it looks right. It looks right. So I'm going to type e over here. I'm going to type e. And that's pretty much the end of it. I'm going to show correct and show solutions, check test. Yes, it looks fine. So any questions regarding quiz number 1? And it has a nice convenient option to print it. I haven't tried it yet, but apparently you should be able to print a test if you take it, once you take the test. So any questions? Quiz number 1, any questions? So in that case, I'm going to move to the second quiz. It's up here. This is on Blackboard, and all the remaining quizzes, it looks like they will all be in Blackboard. At least so far, that's what I think. I don't know if I can actually begin it, so I will try. Let's see, this test cannot be completed because the due date has passed. Test was due, yes, I understand that. So let me see if there is a way. So I will have to stop sharing the screen because I'm going into the grade center and I cannot display students' grades because it will violate your privacy. So I will have to stop sharing for now, and I'm going to ask you to wait a few moments. Is that okay? So I'm going to try to open that test from the grade center. Can you see my screen? No. No. So that's perfect then. So I'm in the grade center and I'm not allowed to display your grades. Just wanted to make sure you're clear about that. So since you cannot see, I'm going to find my name on this list. I hope that it's somewhere here. Well, unfortunately, I don't see myself. I see all of you here, but I don't see myself. Excuse me. Well, in that case, I will probably try to. Okay, well, I guess I will have to. Yeah, I will have to show you this because I don't think I actually have any records of this test for myself. I have your records, but I cannot display because there are grades there. So this is what I will. Yeah, this is me. This is what I took this quiz. You can still read here. Yeah, so let's see. Let's see.
Professor, if you can't access them, do you want me to copy and paste the questions and email them to you?
If you could do that, that would be great.
Yeah, I'll do that.
Yeah, thank you. I apologize for this delay. I actually thought I will be able to. Apparently, it doesn't want to let me do any changes. So let me. So I'm in the grade center again. And like I said, I don't see myself. I only see my students. So let me try again. Maybe I can sort and see better. Let's see. Okay, so
You meet over, Mama?
not yet. Please wait.
Mama, my belly is hurting.
Oh, okay. So you have to wait, please.
Oh, this.
Yes, take it. I'm sorry. So
It actually won't let me access the questions again, but I think one of the students in the chat said that she can send them to you because she wrote them down.
okay, perfect. So yeah, that's great. This Blackboard got so big, so many options that it's so hard to find what you're looking for. That's why. And since I'm an instructor, I don't think I'm actually included, and all my tests haven't been saved as far as I can see. So yeah, it's a complicated program now. It's very hard to find anything, especially if you're using it extensively the first time this quarter. I haven't used it so extensively in the past, so a lot of things here are new for me. Therefore, I will just have to. Well, since yeah, this is really a.
If you let me share my screen, I could show you my quiz.
Is this Melissa?
Huh?
Is this Melissa?
Oh no, this is Kimberly.
Oh,
But
okay.
if you could give me permission on Zoom to share my screen, I could show you my quiz.
Yeah, we can do that if you're okay with that, right?
Yeah.
You okay? Okay, so if that's fine with you, then yes, we can. I'm just going to start Zoom, and I see there's some chat. Okay, perfect. So let's see. Share. let's see, multiple, yes. So I believe you should be able to share your screen with us.
It does show the answers, but this is how it'll show.
Oh, perfect. So I can see the answers, but we just wanted to make sure we can solve the problems, right?
Right.
So this is excellent. Thank you so much. I appreciate this.
No problem.
Sorry for the wasted time. I guess it was a nice break. Just to. Okay, so let's take a look at question number 1. This is a question about a brick that is dropped from the top of a building. We have here the initial height, the mass of the brick, and there is resistance. So is this case 2 or 3?
This would be case 2.
Very good. This is case number 2. That's because instead of v squared, you have v. So your r is given, find the brick's terminal velocity and round to 2 decimal places. Write units with your answer, and there is a suggestion to use m for meters, s for seconds, and kilograms. So let me copy the information, and it's a good idea to tell me which section of the textbook this problem is from, and hopefully the page number. Can you tell me the page number? It's very important that you can identify where is this coming from, this problem. Everything comes from the book, from your homework.
2.3, I think it's page 45.
That's correct. Excellent. Page, well, I would say 41, right? 41 is the closest page where we can find this similar example with,
Okay.
Kimberly, is it possible for me to share my screen now? I think I should be able to do that, right? Yes, I think this is it. And here is my paper. I copied down all the numbers, and I'm going to go to the textbook. You probably have this on an index card. So this should be on your index card. The terminal velocity formula says it's minus mg over r. And this is again page 41, formula 3.7. Formula 3.7, and we're going to place all these values into the formula, and we should be getting our number. So G, by the way, what should we use for G? Any suggestions? Yes, very good, 9.8, because the height is given in meters, and that means we need meters per second. So negative 3.71 times G over R is given, right? So we plug everything in here, in the calculator, negative 3.71 times 9.8 divided by 5.5, and here is our number, negative 661. That's it, right? Because we have to round to 2 decimal places, and because there was a question to provide units, what should I write here?
Meters per second.
Is this correct?
Yeah.
Excellent. So any questions on number 1? All right, perfect. So again, let's move to number 2. If Kimberly could share the screen, that would be great.
I had a quick question just about the final answer.
Yeah, what's the question?
So would positive 6.61 meters per second be a correct answer as well? Because it's just 6.61 meters per second moving in a downward motion rather than.
Yes, I know. So this question came up more than once. Velocity has either positive or negative sign. It's very important. Speed, for example, speed can never be negative, but velocity can be negative. So velocity tells you whether your object is moving upward or downward. And in this problem, it's falling down. The ball is falling down. So yes, it is important. It is important to write minus, right? To write minus with your answer. It's extremely important because this is not speed we're looking for. We're looking for velocity, for terminal velocity. So this minus here has to be in your answer. And if it is missing, then it's wrong. You're saying that your object is going up instead of down, which is wrong. So again, minus is very important. Please keep that in mind. If a similar problem appears on your midterm or final, make sure you have this minus. Extremely important. Very good. So again, let's take a look at the next one, please. Can we still share or do I need to? Oh, so I stopped sharing, right? Oh, perfect. Thank you so much.
No problem.
Very good. So question number 2, we have a brick which is dropped from the top of a building, 445. I'm copying down 445 meters. And the brick has a mass of 174 kilograms. The air resistance is given, and this is again the second case, right? So R is 4.6. Find the brick's position at 11 seconds. Round your final answer to 2 decimal places. There is no need to type any answers, right? So we're not going to type any, any units. There is no need to type units. Excellent. So thank you, and let me go ahead and thank you. And I'm going to share my screen, and we're going to the page number 41 again, right? This is page 41 again, section 2.3, page 41. We're going back to that page, and we're going to use formulas 3.6, right? This is the formula for the velocity. There is an example there, example 3.8, example 3.8, which is very similar to this problem. So the first step will be to realize that the brick was dropped from the top of the building. It was not thrown down with force. It was simply released from the rest position. In other words, I'm trying to say that the initial velocity is equal to 0. Do you agree? So I'm going to use formula 3.6. We're going to substitute V sub 0 equals to 0 into formula 3.6. And this is the formula, V of t equals C times e to the negative RT over M minus mg over R. This is formula 3.6. I'm plugging in a 0 for t. So this is going to be C minus mg over R, from which we get C equals mg over R. M is 1.74, G is 9.8, and R is 4.6. Therefore, let's use calculators. Actually, we don't need parentheses in this case. We just typed all the numbers, 1.74, 9.8 over 4.6. And I'm getting, let me move to the next page. I'm running out of space here. So we have I'm keeping all the digits, 956, 522. So please confirm, are you getting the same C value?
Yes.
Excellent. The reason I'm keeping all those 9 digits is that I don't want my final answer to have a round of error. So I only round my final answer to 2 decimal places, but all intermediate computations will have, 9 decimal places. All right, so we found the C value. Next step is to use the position function. So position function x of t equals, I'm copying this from page 41 right now. And this is the formula to have on your index card. So they call this constant A, and that's what I copied from the book. This is again page 41. You can find this formula on page 41. I copied it exactly. Let's see, minus RT over M. Yeah, I believe I copied this correctly. And the next step is to use the initial position, right? The initial, the height of the building is given 445 meters. We're going to use that. I plug in 445. Oh, I'm sorry, this is the wrong place to plug it. Actually, yeah, x of 0, right? Let me put here x of 0 equals 445, which is equal to minus m times c. We already have c over r e to the 0 minus 0 plus a. So from this, we should be able to find a. A will be 445 plus m times c over r. This is just 1, and this is 0. Therefore, the constant A, so 174, then we have to use this constant C we found earlier up here. Then we divide this by R. So therefore, I'll start by finding this fraction. So 1.74 times 3.706956522 divided by 4.6. And then I'm going to add 445 to this. So 446, 4021966. Can anybody confirm constant A?
Yeah, that's what I got.
Okay, very good. So once we have A, we can answer the question, I believe. So the question was, if I remember, what is the position after 11 seconds, right? 11 seconds. So position after 11 seconds, we will have to plug in all the numbers that we have in this long formula. So it's going to be a little tedious. Minus 174 times capital C and then divide by R. Then we have e to the negative R T over M. Again, pretty tedious. Graphing calculator would probably look good in this case. Use your graphing calculators, or scientific is fine as well, should work fine. 11 here, 4.6, and plus this A here, 446.4021966. And that's pretty much what we have to do. Let's start typing, and make sure to use parentheses whenever you need to use them. So let's see, clear. 1.74, so I put minus up there, times 3.706956522, divided by 4.6. I'm wondering if I put parentheses around my first, no, I didn't. So I'm going to insert parentheses in the front. And the reason is I'm going to close it here, multiplied by e to the power. So second exponential is here, negative 4.6 times 11 divided by 1.74, close parentheses. Then we have to subtract. And again, I'm going to open parentheses just in case. 1.74 times 9.8 times 11 divided by 4.6, close parentheses, and then plus 446.4021966. So close that. Well, and oh, there's an error, so I have to go back. Let's see, second quit doesn't want to do it. Okay, so I'm back to my, oh, there should be no parentheses here, that's why. Okay, so here's the number, 405 point, and I'm going to round it to 2 decimal places, so it's 63. And this would be in, let's see, what is this position, right? In meters, but we're not required to type meters, so I'm going to just type, well, there's nothing to type because it's not my test, right? So I cannot type it. So any questions here? Number 2? Any questions on number 2? So we have, well, we have about 10 more minutes. So let's see. Could we please go back to the test?
Yeah.
Yes, so I'm going to stop sharing. Thank you so much. So maybe we could scroll down and see which question seems to be the most difficult here. It looks like there's 1, 2, 3, 4. There are 4 more questions here. If you want, you can choose one question because I think we have time only for one more. The cooling problem, do you want to look at the cold beer placed into a warm room? Would you like to look at this one? Because I think there was a question, somebody asked me about this one. Question 5. Yes, question 5. So I'm going to look at this one then. So number, so this is a cold beer, initial temperature is given, it's 48 degrees Fahrenheit. It's placed into a warm room at 75 Fahrenheit. Suppose 11 minutes later, we know after 11 minutes, the temperature of the beer is 62 degrees Fahrenheit. Use Newton's law of cooling to find the temperature 29 minutes. So we want to know what's the temperature after 29 minutes. Round your final answer to 2 decimal places. Excellent. Thank you so much, Kimberly. And I'm going to switch back to my Oh, it's here. So share screen. Okay, so let us first identify which section is this from the book. Which section?
2.2.
Yes, very good. This is section 2.2, and
On the homework, there was like a similar one.
so 2.2.
Number 34.
Very good. Yes, we have so 2.2, we had an example on page 31, right? So this is section 2.2. Look at on page 31. We have an example there. We looked at this example in class, and we derived. This is the formula for the temperature, which I would definitely put on an index card. So this is the temperature of the beer. This function describes the temperature as a function of t, time. I'm going to plug all the numbers in here. So we have A is 75, 48 minus 75, e to the negative k. K is not given, we will have to find it. So 48 minus 75. So we have minus 27, e negative kt, all right? So any questions so far? So this is section 2.2, page 31. I would definitely put this formula on an index card to use later. In order to find k, you would need to substitute 11 for t and 62 degrees for capital T. Do you agree?
Yeah, I agree.
Very good, thank you. So we're trying to use this information to identify K, and once we know K, we can find temperature after 29 minutes. So let us solve this. I added 27 times e to the negative k times 11 to both sides. And that means here we have 75 minus 62, 13 right here. Well, this is what I'm getting so far. And take a ln of both sides. So this way we can cancel ln and e. So negative k times 11. And finally, find k by dividing both sides by negative 11. So we get ln divided by negative 11. And again, I'm going to keep all my digits to prevent round-off error later. So this is the value I'm getting in decimal form. You could keep this as this fraction, that should be fine as well. Or you can use this decimal form. So any questions so far? Any questions? Well, we're almost there. We found K. That's half of the battle won. The last step would be to use this function to find temperature after 29 minutes. So I substitute all the numbers in there. Your K is 0.066444. 319, and t is 29. So we should be able to plug this into the calculator. So my answer is 71.07. If you round to 2 decimal places, you would be, I believe I'm getting 71.07. Can anybody confirm this number?
That's what I got.
Excellent, thank you, thank you. So again, this is number 5 from the test. So any questions? Any questions? It looks like we are almost out of time. So any questions regarding this quiz?
I had a question on number 6.
Okay. Can I please see number 6? Let's see, I will stop sharing. Thank you so much. The last one, right?
Yeah, and when we're given a problem like that, how do we know which method to use?
You can use any method you like because it doesn't say, it doesn't specify which method, so it's your decision. You can choose any method. You only have choice between 2, the integrating factor or using the variation of parameters. So choose whichever you like. I would normally go with integration factor because it's my favorite. I like it, so it's my preference. However, if you prefer variation of parameters, you could try that. That's fine. Would you like me to show the steps here?
Yes, please.
All right, let me please, if I could share now my, share the screen. So here is, yes, here is the problem. So first, let me identify A of t. Can you tell me what is A of t in this problem?
-7t.
Excellent, that's correct. So you would have to first move this term to the other side, right? And then you will see that A of t is -7t. And U of t would be e to the negative integral -7t dt, right? This is how we find the integrating factor. And a negative times negative is positive, so we get e integral 7t dt, which is e to the power 7t squared over 2. Is this correct?
Yeah.
Okay, so this is what I'm getting for u of t. Let's see. We're going to multiply both sides of this equation by this integrating factor, which means we multiply each term . And on the left-hand side, I am getting derivative of a product. We're supposed to get derivative of a product by construction. Am I correct so far?
Yeah.
All right, so we have to integrate now, so let's integrate. On the left-hand side, we're just getting our product y times e to the 7t squared over 2 because integral and derivative cancel each other. On the right-hand side, it looks like we have to do substitution here, right? Because this exponent here is a quadratic function. So let's say z, right? z is 7t squared over 2, which means dz is 7 over 2 times 2t dt, and dz over 7 is equal to t dt. Do you agree with this so far? So again, please let me know. And
Do you have done integration by parts or no?
no, I haven't. I'm doing substitution method. There is no
Oh, okay.
need for integration by parts. I believe we can do substitution in this problem. So this will be integral e to the z, and t dt is replaced by dz over 7, isn't it? So this is t dt, and it's replaced by dz over 7. So 7 cancels out, which is very convenient. And here, page 12. So we have y in 7t squared over 2, and on the right-hand side, we have negative. This is e to the z plus c. And that means if you return back to the t variable, you get negative e to the 7t squared over 2 plus c. And final step is to divide both sides by this exponential function. Looks like I'm getting -1 plus c over e to the 7t squared over 2. So this is so far my general solution. Can anybody confirm this?
That's what I got.
Oh, perfect. Thank you. And one more time. So we have initial conditions. So I'm going to substitute 0 in there. So -1 plus c equals 2. So c is 3. So I think we have our general solution. So from this, you can find, I cannot recall, I was supposed to find specific number for this?
Yeah, you just y of 1.
Y of 1, perfect, thank you. So -1 plus replace t by 1 and use your calculators. Hopefully we'll find, let's see, -1 plus 3 over exponential 7 over 2, close. I'm getting this number, 9,1. So this is my answer here. Can anybody confirm this?
I got that.
Excellent. This is Kimberly, right?
Yeah.
Thank you so much. You're so helpful today. I really appreciate. Thank you so much.
No problem.
Yes, you saved us from just doing nothing pretty much. All right. So any questions? All right. So again, as I mentioned, I will try to adjust the number of attempts on your quizzes. I will be in touch with you regarding the plan for the rest of this quarter. So the midterm so far, I believe I'm going to give it on Tuesday, next week on Tuesday. Since we postponed it, it was supposed to happen today, but it will happen next week on Tuesday. So I'm still going to, again, think of the ways to help you with this situation with online tests. And I will let you know as soon as I know for sure regarding this class. So any questions?
Yeah, Professor, just real quick on mine quiz, every time I try to type in the answer to the calculator, the last question, it just gives me a systematic error. It says it's not, or not systematic, like an overload error. Is there like a certain calculator we should be using for this? I just got a regular.
You mean you tried to type something in your calculator and it gives you an error?
Not like an error, like an overload error, like there's too many numbers.
Which problem? Can you tell
The
me
last
which?
question.
Oh, this one, number 6?
Yeah.
Okay.
I mean, mine's a little bit different, but.
This is for the very last calculation here?
Yeah.
For this one? So let's see, did you use parentheses around this exponential here? This is actually very important. So -1 plus 3 divided by, then I type e to the power and then 7 over 2 inside parentheses. You see, if you don't put parentheses around 7/2, it will calculate. You did that, right?
Yeah, mine's not a systematic error. It's not saying that there's an issue. Mine's different. Mine's y to the 9th, or find the 9th variable, I guess. So mine would be like, mine ended up being -10 over 13 plus 179 over 13 divided by e to the 13 over 2 times 9 squared. And it just gives me an overload error. It won't even give me the answer. It's saying there's too many numbers and my calculator's not even calculating it.
So yeah, let me clarify. Are we talking about this problem here, number 6?
Yeah, but mine's different.
So you have different equation, right? Slightly different numbers.
Yeah, mine's y prime plus 13ty equals -10.
Okay.
And then y of 0 is equals 13.
So 13, 10, and 13 like this?
Yeah.
Well, all the numbers because I did check all the answers, none of them are extreme. There are no extreme values there. So if you go with these numbers, replace all of these with your own numbers. Yeah, I would have to look at your computations. Maybe there is something there that causes.
I'll take a picture and email it to you.
Okay, we'll take a look. Yeah.
Okay.
So yeah, I'll take a look and see maybe there's something there. I'll check it and let you know.
Okay.
Okay, thank you.
Thanks.
So any other questions? All right, so in this case, I will end this meeting. I will keep in touch with you, so there could be an announcement soon. Again, let me wish you a wonderful day and please stay safe and healthy. Okay.
Thank you so much.
Thank you. You too.
Thank you so much. Thank you. Okay, bye.